Welcome back to section 5.3. Now we're going to discuss tangent. Now keep in mind, the period of tangent is 1. So looking at problem number 6, everything still kind of stays the same. We're going to add root 3 to both sides to isolate. So the tangent of x equals root 3. Now tangent is positive, so we know we're going to be in quadrant 1 and quadrant 3. Now, when tangent is root 3, that's going to be at something pi over 3. Now that gives us quadrant 1 as is. And now to get into quadrant 3, that's going to be 4 pi over 3. And those are our solutions from 0 to 2 pi. Now, our general form. So I'm going to make a quick sketch. Pi over 3 is here, not drawn the scale. And 4 pi over 3 is down here. So if we think about it, we want to go from one solution to the next. Now, pi over 3 and 4 pi over 3, they're pi units away from each other. And then if I keep adding pi, if you look, I'm just going to keep going from one solution to the next. So when I write my general form, x equals pi over 3 plus, now if I add pi to that, get my common denominator, pi over 3 plus, and that would be 3 pi over 3, is 4 pi over 3. You see that takes me right there to 4 pi over 3? And if I keep adding, I'm at 7 pi over 3, which is up here. 10 pi over 3 is here. 13 pi over 3, and so forth. It's just going to keep going. So to write all of my solutions, it's just n pi. By writing that for general form, that takes care of all of the solutions, because if I just add pi, I'm at 4 pi over 3 as well. So that is all we need. And that's where tangent differs a little bit from sine and cosine. And that's because the period of tangent is 1 as opposed to sine and cosine, which the period is 2. Tangent of x plus 1, subtract 1 from both sides. Tangent of x equals negative 1. Now, tangent. Remember, we're at negative 1. Excuse me, we don't need that. When tangent is 1, when tangent's negative, let's go to that first. Tangent is negative in quadrant 2 and quadrant 4. It's positive in 1 and 3, so it's negative in quadrants 2 and 4. And when tangent is a 1, that's at a pi over 4. To get us into quadrant 2, it's going to be a 3 pi over 4. And to get us into quadrant 4, it's going to be a 7 pi over 4. There's our solutions from 0 to 2 pi. Now, if we're looking at the general form, so once again, here's our 3 pi over 4, and here is our 7 pi over 4. What I do is if I add 3/4, or 3 pi over 4, plus pi, that's 3 pi over 4 plus 4 pi over 4, which is 7 pi over 4. Do you see how it accounts for that next solution? And if we just keep adding pi, we're just going to keep going from solution to solution. So for our general form, x equals 3 pi over 4 plus n pi. There's our general form. Like I said, it varies from sine and cosine because our period is only pi. And now for number 8, subtract root 3 from both sides. 3 tangent x equals negative root 3. Divide both sides by 3. The tangent of x equals negative root 3 over 3. Now, tangent is negative in quadrant 2 and quadrant 4. Now, whenever we see tangent equaling a root 3 over 3, that's going to be at our pi over 6's. To get us into quadrant 2, 5 pi over 6. And then to get us into quadrant 4, 11 pi over 6. Those are our two solutions from 0 to 2 pi. There's our solutions from 0 to 2 pi. Now, general form. For our general form, remember, 5 pi over 6 plus pi is 5 pi over 6 plus 6 pi over 6, which is 11 pi over 6. So it's just going to bring us to our next solution. So our solution in general form, x equals 5 pi over 6 plus n pi. That is all of the solutions for that. That's going to keep bringing us from one solution to the next. And that's where tangent differs from sine and cosine. All right, we'll work on more of these in the next video. Thank you for your time.